Today we're looking at Chapter 5 Test Algebra Review. We're going to solve some problems that you'll see on your test. So these are the setups of the problems, and we'll go over how to solve them. So the first one, we're asked to solve the inequality. So we want to solve this like we would if it had an equal sign and get y by itself. So we're going to add 7. Whatever we do to one side, we do to the other. And we bring down the y, the symbol, and the new number. And then we're going to graph this on the number line. Since it has an equal to line underneath, you have an equal to or an equal to. These are both closed circles. If you have the less than symbol or the greater than symbol without the equal to, those are open symbols. So we're going to do a closed symbol on 12, or a closed circle, sorry, on 12. And it's set up least to greatest, so less than would go towards the left, or as you can see, it's pointing towards numbers less than 12. The next one we're going to solve, actually the next 3 we're going to solve for the variable. So k is here, so we want to cancel out what's on the side with the k. We're going to subtract 8 because it's positive, and bring down, we have k is greater than or equal to 5. Whenever you're reading the inequality, you want to read from the variable. So if it's open towards the variable, it's greater than. If it's pointing towards the variable, like the next one, it would be less than. So this one, we have h divided by 3, so we're going to multiply by 3 on both sides, and we get h is less than 27. The next one is z divided by 5 on the right side, so we're going to multiply by 5. Since this is a fraction on the left side, I'm going to make 5 a fraction as well, so 5 over 1. And I'm going to just multiply my numerators times my denominators. So 5 times 2 is going to be 10. And 1 times 3 is going to be 3. And that's a negative, because 1 positive and 1 negative will make a negative. And then I'm going to keep my same symbol and my variable. This would be read as z is less than negative 10 over 3. The next one, we're going to divide 9.8 divided by 2.8, and that gives us 3.5. And again, leave my k on the right side. My symbol stays the same, and I get 3.5. I would read this one as k is less than or equal to 3.5. The next one, we're going to divide by negative 3. Whenever we divide by a negative or multiply by a negative, we need to flip the symbol. So we're going to make this not less than, we're going to make it greater than, and we get negative 18 over negative 3, which is a positive 6. Then the next one, we need to combine like terms first, so this is more than one step. I would put the t's together, bring the 3t over to be with the 5t, subtract it because it's positive. I get 2t plus 8 is less than or equal to negative 3. And then I'm going to subtract the 8, and I get 2t is less than or equal to negative 11. And finally divide by 2. So t is less than or equal to negative 11 over 2, or negative 5.5. Either way is fine. The next ones have multi-steps as well. The first thing we're going to do, if we see distributive properties, we're going to distribute. So we get negative 3 times w is negative 3w. 3 times negative 6 is negative 18. Bring my symbol down. 2 times 2w is 4w. 2 times 8 is 16. And plus 1 is there. So we then look at each side and see if we can combine like terms on the same side. On the left side we can't, so we're going to bring down the same. But on the right side we have 16 plus 1. Whenever they're on the same side, the numbers or the variable terms, and we want to combine them, we just read left to right. So 16 plus 1 is 17. So we're going to write it as plus 17. And then we want to combine our variables across the inequality symbol. So we do the opposite. This is negative 3w, so I'm going to add 3w. I get negative 18 is less than 7w plus 17. I'm running out of room here. Let me move this down a little bit. So then I'm going to combine like terms. Again, I'm going to move the 17 over to be with the 18. Oops. By subtracting it, I get 7w is greater than negative 35, and then I divide by 7. So w is greater than negative 5. Again, notice I read from the variable. It was open towards the variable, so I read it as greater than. Now the next one, I'm going to erase what we did on the top, so we have some more room. And we have 1.9 plus 1.7x is less than 2.1 times 3 plus x. So we're going to first distribute. We bring down what we have on the left side because we haven't done anything yet to there, and the symbol. We're going to multiply 2.1 times 3, that's 6.3, and 2.1 times x, so 2.1x. I'm going to combine my variable terms. I subtract because it's positive, so I get 1.9 is less than 6.3, and then 2.1 minus 1.7 gives me 0.4. And again, combine my like terms, subtract the 6.3 because it's positive. I get negative 4.4 is less than 0.4x, and finally divide by 0.4. So I get negative 11, and I keep my symbol the same because I didn't divide by negative, so I have x is greater than negative 11. These are compound inequalities, so we're going to solve them separately, and make sure to put the and or the or in between them. So 7w is greater than 14. We're going to divide by 7. So w is greater than 2. And we don't have to do anything to the other one. So w would be less than 3. And this would be my answer. Next one, I'm going to multiply by 3. we get w is less than 3, or subtract 5 and divide by 3, w is greater than 2. If I were to graph these on a number line, I graph them on the same line. This would be both open circles at 2 and 3. Reading from the variable, I have w is less than 3 and w is greater than 2. And that would be my answer. Now notice that this is an or, but it goes together as an and. That's okay, but if it's an and it doesn't go together as an and, then that would be considered no solution, because you can't have a number within a range if the lines are never going to cross on your number line. Here's another or with multi-steps, so we're going to subtract by 2 first. 3x is greater than 6, and divide by 3. X is greater than 2. Or, again, subtract by 4, that's a positive 4. This time I bring down the negative 7x, because that minus sign applies to the 7, not the 4. This becomes negative 21. And I divide by a negative, which flips my symbol to be greater than or equal to 3. These two are going to go the same direction, which is also fine for an or. Closed circle at 3, open circle at 2. They're both greater than, so they're going to unite. With absolute value inequalities, you're also going to get 2 answers for each, but the symbol is going to tell you how to set them up. So if it's a greater than symbol, I remember it by greater, so this is going to be an or. I'm going to solve the first one just like it's written, but I'm going to put an or, set up the second one with the left side the same, but then I'm going to flip my symbol and make the right side negative. And solve. So we're going to subtract 4. We get z is greater than or equal to 3, or subtract 4, and z is less than or equal to negative 11. The next one is a less than symbol, an absolute value. That's going to tell us that it's an and. So again, we set up the first side the exact same way, but we put an and in between, and we get w minus 1 again is greater than or equal to negative 4, so flip the symbol and make it negative, and then solve both. W is less than or equal to 5, and w is greater than or equal to negative 3. The last absolute value we're going to again set up as an and. Now there's another way to set this up as an and that's to put the values with the variables in the middle. Rewrite this exactly the same, but then put the symbol on the other side of the variable and make a number negative. So this way can be set up, or you can use the same way we used for this one here. Doesn't matter. Whatever's easier. If you set it up this way, though, you're going to come from the middle out. Whatever you do to the middle, you're going to do to both the right and left sides. So I have 2x is less than 8, greater than 2. Divide by 2. X is less than 4 and greater than 1. Notice I read from the variable. The next one is an absolute value inequality that we're going to write and solve. And the reason why I know it's absolute value is it tells us find the range. The key word here is range to help us determine that we need to write an absolute value equation. So absolute value is always x minus the given, which is the total. So if he has 4,500, we're going to put that as our given. And with absolute value, it's always less than or equal to what it's within. So it's within 1,300. So we're going to do less than or equal to 1,300. So the symbol always is the same, and the setup in the absolute value symbols are also always the same. And then we're going to solve. So we set it up as an and. We still have to flip the symbol and make the second part negative, but we have an and in between. So we're going to add 4,500 to 1,300. We get 5,800. So x is less than or equal to 5,800. And add the 4,500 again, but this time to negative 1,300. So I get 3,200. So x is greater than or equal to 3,200. And this would be my answer. Next one you're going to have to do on a graph paper, or they will provide the graph for you on the test. But I'm going to draw my graph here. So notice I do not have a y-intercept here, but when graphing, you always need this to be in slope-intercept form. So this is in slope-intercept form if I consider it y equals 3x. It just doesn't have the intercept, which means that I start at 0, 0. So I'm going to put a point at 0, 0. And then my slope is 3, or 3 over 1, which tells me to go up 3 over 1. I can do that again. I can also do that from the starting point and go down 3 to the left 1. Then I look at the type of symbol that I have. When I have less than or equal to or greater than or equal to, it's a solid line. And then if I have less than or greater than without the equal to, it's a dashed line. So this is a solid line. And then my last step is to pick a test point that's not on my line. Usually I want to say that you can pick 0, 0, but since 0, 0 is on my line, I'm going to look for another point. It can be any point as long as it's not on my line. So let's say I do make it easy on myself and do 1, 1. I'm going to plug in 1 for y, keep my symbol, plug in 1 for x, and I'm seeing whether this makes a true statement. So is 1 less than or equal to 3? Yes. So here's 1, 1. We're going to shade towards the 1, 1. So from my line towards the 1, 1, all this. Next one is not in slope-intercept form, so we need to make it into slope-intercept form first. We're going to move the x term over. So I get 2y is less than 4x plus 8. Still not totally in slope-intercept form, so we're going to divide by 2 to get y by itself. So y is less than 2x plus 4. Now we have it in slope-intercept form, so we're going to graph y equals 2x plus 4. That tells us to start at 4 on the y-axis, and my slope is 2, or 2 over 1, so that means go up 2 over 1, or down 2 to the left 1, and I have my line. Now, to do my line, I need to look at my symbol, which is now a less than without an equal to, so this is going to be a dashed line. And then my last step is to pick a test point. This time I can pick 0, 0. So I'm going to plug it in. 0 is less than 2 times 0 plus 4. So 0 is less than 4, which is true. So here's 0, 0. We're going to shade towards 0, 0. Starting from my line that I drew. The next one, we're going to look at the graph that they've already drawn and come up with the inequality from it. So the first thing I would do is try to come up with the equation, see where it crosses the y-axis. It looks like it crosses at -1. So that's going to be my y-intercept. Then I need to find my slope. It goes up 2 over 1, it looks like, which is a positive 2 over 1, or just 2. So then I have my 2x as my slope. I know it's going to have a y if it's in slope-intercept form. I just need to come up with my symbol. Now it's a solid line, so it's either going to be a less than or equal to or a greater than or equal to symbol. I look at my shading. If I plug in 0, 0, it looks like it's shaded towards 0, 0. So 0, 0 needs to make a true statement. So if I plug in 0 here and 0 for x, I have 0 is something to -1. Well, what would make it true? It would have to be greater than or equal to -1. So that tells me my symbol is greater than or equal to. And my last question here is making an inequality and solving. So Matthew is shopping for shoes and socks. He has $75 to spend. That means he has no more than $75. So my symbol always comes before my total. So it has to be less than or equal to $75. The shoes he likes cost $28. The socks cost $4. We don't know how many shoes and socks he can buy, so we're going to just do by price $28 for the shoes, which we could do X, plus $4 for the socks, which we need to do a different variable because they're different things. And we have our inequality. And then the second part, to answer the question, can Matthew buy 2 pairs of shoes and 5 pairs of socks with what he has? We're going to plug in 2 for X, because that's our shoes, 5 for Y, that's our socks. We're going to see if this makes a true statement. So 28 times 2 is 56, plus 20 has to be less than or equal to 75, which we get 76. So is 76 less than or equal to 75? No. So he cannot buy 2 pairs of shoes and 5 pairs of socks. And that concludes Chapter 5, Test Review for Algebra.